Okay, looking at problem number 1 on your chapter 2 review. Number 1 says we've got this equation f of x equals 1 over x. And the directions say use the definition of a derivative to calculate the derivative of f of x equals 1 over x. So the very first thing we have to do is we have to write down our definition of our derivative. So the definition of the derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So now we have to go ahead and substitute in x plus delta x into my equation. And so when I substitute it into my equation, you'll notice that this becomes 1 all over x plus delta x. So then it says let's go ahead and subtract f of x. Well, here's my f of x. So I'm going to subtract my f of x. And then that is going to be all over delta x. So I've got the limit as delta x approaches 0 of 1 over x plus delta x minus 1 over x all over delta x. Now that I've substituted that in, I notice I've got a complex fraction here. Got fractions inside of fractions. So the rule is, if you have a complex fraction, you're going to go ahead and multiply the entire thing by the least common denominator. So you notice your denominator here is x plus delta x. You've got a denominator of x, and then you have this denominator is just 1. So my common denominator is going to be x times x plus delta x. So I'm going to go ahead and multiply my first term by x times x plus delta x. And when I do that, I notice the x plus delta x, they're going to cross out. Now when I multiply my second term by x times x plus delta x, it's the x's that cross out. And then when I multiply my denominator by x plus delta x, nothing crosses out, and I'm just left with delta x times x plus delta x. So you're going to see that right here. You just ended up with your x, because the delta x is crossed out. You ended up with just minus x plus delta x because the x is crossed out. And then when I multiply down here, I'm left with delta x times x plus delta x. Now that I've done that, I'm going to go and distribute my negative and simplify my equation. So when I multiply by my negative and distributing it on through, you're going to notice that x minus x, those are going to cross out, and then I'm going to be left with that negative delta x. And this is still all over delta x times x plus delta x. Now that I've gone ahead and simplified my numerator, I can go ahead and cancel my delta x's. So delta x divided by delta x gives me this negative 1. And then notice my numerator, or sorry, my denominator, I still have my x times x plus delta x. Now to finish this problem off, I'm going to go ahead and take my delta x and I'm going to replace it with 0. So this is the limit as delta x approaches 0, so I need to substitute in 0. So when I substitute in 0, that's just going to leave me with this x times x. And x times x is negative 1 all over x squared. And that is your answer to number 1. Now on number 2, the directions say on number 2 that it wants me to take this equation. It says I got y equals 2x divided by 1 minus 3x squared. To solve this equation, I'm going to go ahead and use my quotient rule. My quotient rule says take the derivative of the numerator. So the derivative of 2x is 2. I'm going to leave the denominator the same. So this stays 1 minus 3x squared. And then I'm going to subtract. I'll leave my numerator the same. And then I'm going to take the derivative of the denominator. So the denominator of 1 minus 3x squared is going to be negative 6x. Now to finish off my quotient rule, it says take the denominator and square it. So there's my calculus part. I've got 2 times 1 minus 3x squared minus 2x times negative 6x all over 1 minus 3x squared squared. So now I need to go ahead and simplify this. So to simplify this problem, you're going to notice I'm going to go ahead and distribute the 2 on through. So this leaves me with a 2. I'm going to distribute the 2 to the negative 3x squared. That gives me negative 6x squared. And a negative 2x times negative 6x is going to give me a positive 12x squared. And that is still all over my denominator squared. Okay, and I'm going to combine any of my like terms. So combining my like terms, I notice that I have a like term right here of negative 6x squared plus 12x squared. That's going to give me 6x squared. I still have my 2, and that's still all over my denominator squared. So that's my answer to number 2 is y prime equals 2 plus 6x squared all over 1 minus 3x squared squared. So now as I go to my next problem on number 3, I've got y equals the square root of 2x plus 1 all over times x cubed. And the directions say it wants me to find dy dx, or remember dy dx is just the derivative. So to find the derivative, I'm going to have to use my product rule. So my product rule says I'm going to take the derivative of the numerator, the derivative of my first term times my second term. And then I'm going to take and leave the second term the same, plus, I'll leave the first one the same, times the second one. Now when I do this right here, if I want to, I can just remind myself that this is just the same thing as this to the 1/2 power. So it might help me to go ahead and remember my chain rule a little bit better, because here's my outer equation. So my outer equation would be 1/2 times 2x plus 1 to the negative 1/2. And then here's my inner equation, which is 2x plus 1. And so the derivative of 2x plus 1 is going to be 2. And now I'm going to go ahead and leave my second equation the same. So that's times x cubed. And then I need a plus sign. Now I'm going to leave my first equation the same. And times the derivative of my second equation. So the derivative of my second equation is 3x squared. Okay, now that I've done that, I need to simplify down my problem a little bit. So I'm done with my calculus. I just need to go ahead and remember that anytime that I have a negative power, so here's a negative 1/2, that's going to put it in the denominator. And then I change that back to the square root. So now I've got x cubed all over the square root of 2x plus 1 plus the square root of 2x plus 1 times 3x squared. So now to simplify this down, I need to remember that I need a common denominator. So I can add my numerator, keep the same denominator. So as a reminder, this denominator right now is 1. And this denominator is the square root of 2x plus 1. So that means my common denominator is going to be the square root of 2x plus 1. So I'm going to multiply both numerator and denominator by the square root of 2x plus 1. So when I multiply that on through, this is what happens. So notice on this side, I already have my common denominator, so this side stays the same. Now on this side, when I multiply the square root of 2x squared plus 1 times the square root of 2x plus 1, notice that just leaves me with 2x plus 1. And then I still have my 3x squared, and that's all over the square root of 2x plus 1. So now I'm going to go ahead and distribute my 3x squared on through. So when I do that, and I distribute it on through, I've got 3x times 2x is going to give me that. Sorry, the 3x squared times 2x gives me 6x cubed. And then when I take 3x squared times 1, I get 3x squared. So now I'm going to add my numerator, keep the same denominator. That's my laws of fractions. So when I add my numerator, I've got x cubed plus 6x cubed gives me this 7x cubed. I still have my 3x squared. And then that is all over my common denominator, which is the square root of 2x plus 1. And that is my derivative, or my answer to number 3. I've got 7x cubed plus 3x squared, all to the square root of 2x plus 1. Now this next problem on number 4, I've got f of x equals the cotangent cubed of the square root of x. Now you'll notice this is a classic problem where you are using your chain rule, because we've got a lot of composite functions. So the very first thing that I do, just to remind myself of my composite function, is I'm going to rewrite this to this right here, the cotangent squared of x, all to the third power. Now the reason why I do this is because it's going to help me to identify all of my outer and inner equations that I need to take the derivative of. So here's my first outer equation. And so when I do that, remember your rule is take 3, multiply by the front, and then you subtract 1. So that becomes 3 times the cotangent squared of x, all to the second power. So that is my outer equation. Now my next equation coming in is the cotangent of the square root of x. So we know the derivative of the cotangent is negative cosecant squared of the square root of x. So you'll make sure to memorize your trigonometric derivatives so that you can go ahead and answer this question. And now the next equation in is the square root of x. So I take the derivative of the square root of x, and that becomes 1/2 x to the negative 1/2. So there I've done my calculus. I've got the derivative is 3 cotangent square root of x squared times negative cosecant squared root of x times 1/2 x to the negative 1/2. I just need to do some algebra to simplify this down a little bit. So you're going to notice my algebra that I do. First off, I'm going to take this negative sign, and just to make it look better, I'm just going to put it out front. So I've got a negative 3 right here. I still have my cotangent square root of x squared. I write it in its algebraic form, which is cotangent squared square root of x. Now I still have my cosecant squared square root of x. Now notice this 2 is in the denominator, so it goes in the denominator. And now this right here, let me just scroll down to it so you can see it. I've got a negative 1/2 power. So since I have a negative 1/2 power, to put that in the denominator, it becomes plus. So here it is right here. And that is x to the 1/2, and I just change it to the square root of x. So the answer to number 4 is going to be f prime of x equals negative 3 cotangent squared root of x, cosecant squared root of x, and this is all over 2 square root of x. Okay, let's go ahead and take a look at problem number 5. So in problem number 5, it says we have this equation. It says we got y equals 1 minus x all over 2 minus x. So on this problem right here, the directions say, on number 5 it says find, and then it says it says d squared y all over dx squared. We need to remember that that notation stands for the second derivative. So we want to find the second derivative of this equation. So we have to first find our first derivative, and then once we're done finding the first derivative, we'll go ahead and take the second derivative. So this problem right here, we're going to follow our quotient rule. So remember the quotient rule says take the derivative of the numerator. So my derivative of 1 minus x is going to be negative 1. And it says leave the denominator the same. So here's the same denominator. So then next comes my minus sign. And then it says that I'm going to leave my numerator the same. So here's my numerator. It's 1 minus x times the derivative of the denominator, which is negative 1. And then that is all over the denominator squared. So here's my denominator squared. Okay, now that I'm done with my calculus, following my quotient rule, I need to go ahead and simplify this problem down. So notice I'm going to go ahead and distribute my -1. So this is going to leave me with a -2. I'm going to distribute my -1 to my -x. That leaves me with a positive x. Now notice with this other side, I'm going to distribute this -1 and this negative sign also. So I've got a -1 times a -1, which is a +1. And then when I distribute this -1 to this -x, and I distribute this negative on through, it actually becomes a -x. So in my numerator, I now have -2 plus x plus 1 minus x. And that's still all over my denominator being squared. So now to simplify this down, I'm going to cross out any terms that are alike. So I notice that x minus x is 0. Now I'm going to combine my -2 and my +1. That's going to give me a -1. And then it's still all over my denominator being squared. So that is your first derivative. Your first derivative is -1 all over 2 minus x squared. Okay, now I'm going to go ahead and find the derivative of -1 all over 2 minus x squared. The first thing I notice is I don't have an equation divided by an equation. So since I don't have an equation divided by an equation, I don't have to use the quotient rule. So what I'm going to do is I'm going to rewrite this so I can make my problem a little bit easier. So here's this 2 minus x squared. So I'm going to change this power to a negative. And then when I change it to a negative, that means that I can move it up to my numerator. So to actually derive this, I'm going to make my problem a little bit easier by just deriving -1 times the parentheses around 2 minus x all to the -2 power. So when I do that, I need to go ahead and use my chain rule. So here's my outer equation. So my outer equation says I take this -2 times this -1, which becomes this +2, and then I subtract 1 from my power. So 2 minus 1 is -3. And then I take the derivative of what's inside. So the derivative of what's inside is -1. Now that I've done that, I've got my second derivative. Now I just need to go ahead and simplify it down. So to simplify it down, I notice this -3. I'm going to return it to its denominator by changing it to a positive. And then this -1 times 2 is going to give me this -2. So my second derivative of this equation is -2 all over 2 minus x to the third power. Now looking at the problem on number 6. On number 6, it says that it wants me to take this equation. So the directions say the position equation for the movement of a particle is given by s equals t to the third plus 1 squared, where s is measured in feet and t is measured in seconds. It says find the acceleration of this particle at 1 second. So remember that acceleration is my second derivative. So since acceleration is my second derivative, I need to go ahead and find this second derivative of this equation. So since I have to find the second derivative, I decide to not use my chain rule because it'd be easier if I go ahead and FOIL this out first and then find the second derivative. So I take this equation right here. I got t cubed plus 1 all to the second power. I'm going to FOIL that out. So notice when I do firsts, I've got t cubed times t cubed, which is going to give me t to the 6th. Outsides is going to be t cubed times 1. And t cubed times 1 plus t cubed times 1 is going to give me this 2t cubed. And then last is going to be plus 1. So if you need to, you can write that down twice and FOIL it out. Now that I've actually got it written, so that my position function is now t to the 6th plus t2 cubed plus 1, I can go ahead and find its derivative. So remember the first derivative is velocity. So when I derive this position function, I've got t to the 6th. So I multiply by 6 and I subtract 1. And so that's going to give me 6t to the 5th. So 2t to the 3rd now becomes 6t squared. So that's my velocity equation, 6t to the 5th plus 6t squared. Now to find my acceleration equation, I go and take my velocity equation, and I find its derivative. So to find the derivative of this equation right here, I'm going to take 6t to the fifth, so I multiply 5 times 6, and I'm going to get 30. And I subtract 1, and that's going to give me 32 to the fourth. So I take 6t to the second, I multiply, 6 times t is 12, and I subtract 1, and so that's going to be plus 12t. So now I found my acceleration equation, which is 32 to the fourth plus 12t. So the instructions say wants to find the acceleration of this particle 1 second. So my acceleration of 1 second, so I'm substituting in 1 into my acceleration equation. So I get 30 times 1 to the fourth plus 12 times 1. I simplify that down. So 30 plus 12 is going to give me 42 feet per second squared. And that is the acceleration at 1 second. And that is the answer to number 6. Now looking at number 7. So on number 7, it says that I have this equation y equals x all over x plus y. And my directions on number 7 says that it wants me to find y prime. So I'm going to find the first derivative. You'll notice that since there is a y here and also here, I'm going to have to use implicit differentiation. Implicit differentiation says every time I derivate a y, I write y prime. So I take the derivative of y, I get y prime. Now over here, I'm going to have to use my quotient rule. So my quotient rule says the following. It says take the derivative of the numerator, so the derivative of x is going to be 1, times the denominator, which is x plus y. And then next comes my minus sign. And now I'm going to take the derivative, or I leave the numerator the same, so that is x times the derivative of the denominator, which is x plus y. So the derivative of this x becomes 1, and this derivative of y is also 1. And since I am now just taking the derivative of y, I have to write y prime. And then this is going to be all over my denominator squared. So now I've got y prime equals 1 times x plus y minus 1 plus y prime times x. So I just need to go ahead and simplify this down and solve for y prime. So my first step on this is I'm going to go ahead and distribute the 1 on through. So distributing this 1 on through, I get 1 times x is x. I've got 1 times y is y. I'm going to go ahead and distribute this x on through. And at the same time I'm doing that, I'm going to distribute this negative on through. So this becomes negative x. And distributing this x to my y prime, this negative there, that becomes negative xy prime. And then that is going to be still all over x plus y squared. So now I've got y prime equals x plus y minus xy prime all over x plus y squared. Okay, now I'm going to go ahead and simplify my numerator. So to simplify my numerator, I notice that I can cross out the x's, and then I'm just going to be left with this y minus xy prime. So I've got y minus xy prime all over x plus y squared. So now to simplify it even further, I'm going to go ahead and multiply both sides by x plus y squared. So now you're going to notice I have y prime times x plus y squared equals y minus xy prime. Now the reason why I do this is because I need to get my y primes next to each other, because I need to go ahead and factor those out. So notice here is my xy prime. I need to move it to the other side by adding it. So I'm going to take, I've got still my y prime times x plus y squared. Now notice I add this to the other side, so I've got plus, I have my xy prime, and that all equals y. Now that I've done that, I can factor out from this side right here my y prime. So I factor that out, put it out front, and when I do, I'm just left with this x plus y squared plus x. So now my last step, now that I've done that, is I'm going to divide both sides by x plus y squared plus x. So dividing both sides by x plus y squared plus x is going to cross out on this side, and I'm going to be left with y prime, and when I divide that over here, I end up with y all over x plus y squared plus x. And so that's going to be your answer to number 7. You got y prime equals y all over x plus y squared plus x. Now looking at this next problem on number 8. Number 8 says I've got this equation, x all equals the cosine of y. So I'm going to go ahead and differentiate this. The directions on number 8 says that it wants us to find dy dx. dy dx means take the derivative. So I'm going to take the derivative of x, which is equal to 1. I take the derivative of cosine of y, which is negative sine of y. Then I take the derivative of y, which is 1. Then I just differentiated a y, so I have to write y prime. So on this problem right here, I'm using implicit differentiation. So now that I've got my calculus part done, which is 1 equals negative sine of y all over y prime, I'm going to use my algebra. And my algebra just says I need to go ahead and divide both sides by the negative sine of y. So that's my next step. I divide by negative sine of y. I end up with 1 all over negative sine of y equals y prime. And now to finish this off, the reciprocal of 1 all over negative sine of y, its reciprocal is going to be the negative cosecant of y all equals y prime. And that is going to be your answer to number 8. As negative cosecant of y equals y prime. On number 9, I'm given this equation on number 9 that says f of theta equals the secant of theta squared. So to solve this one, I'm going to use my chain rule. And notice this is my outer equation. So my outer equation says take the derivative of the secant of theta squared. So the derivative of the secant is secant of theta squared, tangent of theta squared. So those are my derivative of my secant of theta. And now I'm going to take the derivative of the inside. So the derivative of the inside is 2 theta. Now all I have to do is just simplify a little bit algebraically. There's not much more that I can do with this. All I'm going to do is I'm just going to move this 2 theta out front. And there's my answer. So my answer is going to be 2 theta times the secant of theta squared times the tangent of theta squared. Let's take a look at number 10. So number 10, it says that I have this equation. It says I got y equals the sine squared of x minus the cosine squared of x. So I'm going to rewrite this algebraically just to remind myself that I need to use the chain rule, because the sine squared of x is the sine being squared. So that's sine of x squared. And then cosine squared of x is cosine of x squared. So now I want to go ahead and find its derivative. So on number 10, the directions say differentiate. So here's my outer equation. So the outer, you multiply it, and then you take it to the 2 minus 1. So you got 2 sine of x all to the first power. And then we're going to go ahead and take the derivative of what's inside. So the derivative of the sine of x is the cosine of x. So I've got 2 sine of x, cosine of x, doing my outer and my inner. Now I do the exact same thing for the cosine of x squared. So here's my outer equation. So now when I derivate this, I get 2 cosine of x. Then I take the derivative of what's inside. The derivative of what's inside is the cosine of x. So that gives me the negative sine of x. Simplify this down, leaves me with 2 sine of x plus, so this negative negative makes this a positive right here. So I've got 2 sine of x cosine of x plus 2 sine of x cosine of x. And those are like terms. So when I add those together, I get this answer of 4 sine of x cosine of x. So notice I will accept this answer. This is where we can stop. But if you are going on calculus 2, make sure you start to memorize those double angle formulas because they use them a lot in calculus 2. So notice this matches a double angle formula. So my double angle formula is 2 sine of x cosine of x. That's a double angle formula. So I separate out my 4 to 2 times 2 because I'm going to use that 2 sine of x cosine of x to match my formula. And when I do that, this 2 sine of x cosine of x is the sine of 2x. And that's off your formula sheet. Let's start to memorize that if you are going on to calculus 2. So your answer is y prime equals 2 sine of 2x. And I'll also accept that answer. In fact, this is the preferable answer, especially if you're going to be going on calculus 2. So on this next problem on number 11, so on number 11 it says we have this equation. It says we got f of x equals the square root of x plus 1. And it says on the directions, find an equation of the tangent line to the graph of f of x equals the square root of x plus 1 at the point where x equals 3. So remember, anytime that you're finding a tangent line equation, so if I'm going to scroll down here, I'm going to show you, you have to use your formula. Y minus y sub 1 equals m times x minus x sub 1. So in other words, I need to find my x and y value that I'm going to be able to substitute in my equation. So the first thing I do, I notice is that here's my x value, which is given to me. So this x value is 3. They don't give me the y value that goes with that point, so I have to substitute it into my original equation. I got 3 plus 1 is 4, and the square root of 4 is 2. So in my formula, this would be my x sub 1, and this would be my y sub 1. Let's go ahead and find the slope. I have to find the first derivative. So my first derivative, remember the square root of x plus 1 is the same thing as x plus 1 to the 1/2. So since this is x plus 1 to the 1/2, using my chain rule, so here's my outer, this gives me 1/2 times x plus 1, and then when I subtract 1 from 1/2, I get negative 1/2. And then I take the derivative of what's inside, and the derivative of what's inside is 1. So that derivative is 1/2 times x plus 1 to the negative 1/2 times 1. I simplify it down. Remember, negative 1/2 power puts it in the denominator. That changes it to a positive 1/2. 1/2 power is the square root. And so here is my slope equation, or my derivative, which is 1 over 2 times the square root of x plus 1. So to actually find the slope that I'm going to use in my formula, I have to find the value at the point 3. So I'm going to take my number 3, I'm going to substitute it right into here. So I got 3 plus 1 is 4, and the square root of 4 is going to be 2, and so that's still 2 times 2, and so that gives me a nice slope of 1/4. So now going to my equation for the tangent line, which is y minus y sub 1 equals m times x minus x sub 1. You're going to remember they gave you the point 3 for your x sub 1. So I'm going to go ahead and substitute in point 3. And we found the y sub 1, and we substituted that 3 into my original equation, so that was 2. And then here is my slope, which is 1/4. Now that I've substituted those numbers in, I'm going to go ahead and distribute and simplify. So notice y minus 2 is going to stay as y minus 2 for right now. going to distribute this 1/4 on through, so I get 1/4 x minus 3/4. So now I add 2 to both sides of my equation. So when I add 2 to both sides, I've got negative 3/4 plus 2. Well, 2 is actually 8/4. So I add my numerator. So negative 3 plus 8 is 5/4. And this will be your answer, y equals 1/4 x plus 5/4. Now, if you want to get what the book has for the answer, all they do is they just multiply everything by 4. And then they just put it all on one side. When I multiply by 4, I get 4y. When I multiply this next term by 4, I get just x. And when I multiply this next term by 4, I get 5. Now to put it into what's called standard form, that means everything is just on one side of the equal sign. I just move this 4x over here. So another way to see the answer is x minus 4y all the way plus 5. Okay, on problem number 12, it says find the values of x for all points on the graph of f of x equals x cubed minus 2x squared plus 5x minus 16, at which the slope of the tangent line is 4. So the first thing that we need to do is we need to go ahead and find our slope equation. So remember, your slope equation is your first derivative. So I'm going to go ahead and find my first derivative. So the derivative of x cubed is 3x squared. The derivative of negative 2x squared is going to be negative 4x. Your derivative of 5x is 5. And then, of course, the derivative of negative 16 is 0. Now, once I found my derivative, it wants to know where this derivative has a slope at 4. So in place of f prime of x, I'm going to substitute in 4. So substituting in 4, I've got 4 equals 3x squared minus 4x plus 5. Now I need to go ahead and do some algebra to solve this problem. So I need to go ahead and move that 4 over to the other side. So I'm going to subtract 4 from both sides. When I subtract 4, I end up with the equation of 3x squared minus 4x plus 1. Now that I've subtracted my 4 from both sides, I have my equation 0 equals 3x squared minus 4x plus 1. I just need to go ahead and factor this equation. So factoring this equation, 3x squared minus 4x plus 1, you're going to notice that I have my factor of my first term, which is 3 and 1. Factor the last term, which is going to be 1 and 1. And since that is a negative 4 in the middle, that means I'm going to need a negative 1 for my factors of my last term. So notice this right here would be my outsides. These are my insides. Substituting those in, I put my outside at 3. I put my other outside at negative 1. Now that I've done that, I just remember first, so I ask myself what times 3 is going to equal 3. And so that answer is 1. And then what times negative 1 is positive 1 for my last. Negative 1 times a negative 1 gives me that positive 1 for my last. Now that I've factored my problem, 0 equals 3x minus 1 times x minus 1, I just have to solve each one of these individually. And I get x equals 1/3 and x equals 1. And that would be your answers to number 12. So going on to number 13. Number 13 says that I have this equation here. R equals 2x squared plus 1 over x. And the directions on number 13 just says find the instantaneous rate of change of r with respect to x if r equals 2x squared plus 1 over x. Well, instantaneous rate of change is just another way of saying find your derivative. So to find the derivative, I'm just going to go ahead and take the derivative of my equation. So the derivative of r with respect to x is dr over dx. I'm going to take the derivative of 2x squared, which is equal to 4x. Now to take the derivative of 1 over x, if you want, you can go ahead and rewrite that as x to the negative 1. Following my laws of the power rule for my derivatives, I take negative 1 and multiply by 1, and then I subtract 1. So that's going to give me negative 1 x to the negative 2. And then that becomes negative 1 over x squared. So on this problem right here, the key to it is, you just have to remember that instantaneous rate of change is just your first derivative. And then you just go ahead and derivate it, and you get the answer of dr over dx, all equals 4x minus 1 over x squared. On this next problem, on number 14, says that we have this equation. S of t equals negative 16t squared minus 26t plus 220. So number 14, it says an object is thrown straight down from the top of a 220-foot building with an initial velocity of 26 feet per second. Write the position equation for the movement described. So this is actually from physics. Your negative 16 right here is going to be half of your gravity. This negative 26, well, that is your original velocity. So you're going to notice they're throwing this downward with initial velocity 26 feet. And then this 220 feet is going to be your position. So this first part is half of gravity. And since the pull of gravity in feet is 32 feet per second, half of 32 is negative 16. This is being thrown downward. This is your velocity. And this, of course, is your original position. Now, on your test, you won't have to worry about writing the equation. It will be given to you. But for those of you that are in physics, this is just kind of a way to help you out to remember what each part of your quadratic positions are in your quadratic equations. So you don't have to worry about this. I wrote on here the equation will be given on the test. You don't have to worry about that part. So now I just have to find its derivative, because the question is, what is the velocity at 1 second? So remember, the first derivative is your velocity. So when I take my derivative of my position, which in physics is represented by s of t, I get v of t. I take the derivative of negative 16t squared, which is negative 32t. I take my derivative of negative 26t, which is negative 26. And of course, my derivative of 220 is going to be 0, so I don't have to worry about that. Now, to finish this problem off, I want us to know what is the velocity at 1 second. So to find that velocity at 1 second, now that you found your velocity equation, which is your first derivative, I'm just going to go ahead and substitute in 1 for t. So you'll notice I have v of 1. So velocity 1 second, substituting in 1. So I get negative 32 times 1 minus 26. And that's going to give my answer. Negative 32 minus 26 is negative 58 feet per second. So that is the answer to number 14. The velocity 1 second is negative 58 feet per second. Okay, looking at this last problem on number 15. So on number 15, the directions say, it says, as a balloon in the shape of a sphere is being blown up, the volume is increasing at the rate of 4 cubic inches per second. At what rate is the radius increasing when the radius is 1 inch? Well, the formula for your volume for a sphere is volume equals 4/3 pi r cubed. And as on number 14, one thing to note, your equation will be given on your test. You don't have to worry about memorizing all the equations. You should start to remember some of them, though. Some of them are used quite a bit. So basically, this is a related rates problem. In other words, if you look at the question carefully, we are taking this volume with respect to time. And so since we're doing it with respect to time, when I go ahead and take the derivative of my v, which is 1, I have to remember that that is going to be dv all over dt. In other words, you can kind of think of it this way. It's the difference of the volume with respect to the difference of time. Okay, now I'm going to go ahead and take the derivative of 4/3 pi r cubed. So I multiply the 3 times the 4/3. That's going to give me the 4. And then remember, you subtract the 1. Remember, the pi is constant, so I'm just going to hold it constant in here. And 3 minus 1 is going to be r squared. And since I am deriving this with respect to time, I have to write in dr dt. That is the difference of the radius with respect to time. Now that I've gone ahead and taken the derivative of this, now I'm ready just to substitute in the numbers and find the answer to what the equation is asking. The equation is asking at what rate is the radius increasing when the radius is 1 inch. So you're going to notice the part that represents the increase of the radius is dr dt. So it wants me to find dr dt. So that means that there is enough information in my problem that I'm going to go ahead and be able to substitute in those numbers so that I can find my answer. So you're going to notice that in the problem it says the volume is increasing at a rate of 4 cubic inches per second. So there's your change in your volume. So the change of the volume is going to be 4. So I substitute in my equation 4. And notice here's my 4 that stays the same, pi that stays the same. And then in the problem it says that the radius is 1 inch. So here's my radius, which is 1 inch. So in the problem it actually gave us this right here, dv over dt is equal to 4. And it gave us also the radius is 1 inch. And then it just basically wanted me to find dr dt. So once you have your equation in the derivative form, it's just actually just a matter of substitution. So I take 4 pi times 1 squared, that's going to give me 4 pi. That all equals 4. So my last step is just to divide both sides by 4 pi. And when I divide both sides by 4 pi, simplify it down. So 4 divided by 4 pi, the 4's cross out, and it looks like you're just going to be left with the answer of 1 over pi inches per second. And that is our unit. So that would be the answer to change of the radius with respect to time. Now, of course, if you want, you can go ahead and divide that out. That's perfectly fine. But I'll just go ahead and leave it as 1 over pi inches per second. And that is the answer to number 15.